Hi, this is question number 12. Uh, Here, I feel like there is some mistake in this question, especially in the options. So let's discuss why I think so. There is P is equal to this summation and Q is equal to this summation. And you have to figure out which options are right. And options look like basically P is greater than 5 by 6, Q less than 5 by 6, and Q greater than 5 by 6 and P less than 5 by 6. Basically, near 5 by 6, all of the options are, and we have to figure out what is the relationship. So let's think about what is going on here. If you look at the term inside the brackets, both of them are same, right? So P and Q are the summations of the same quantity, right? It's just that the limits of the summation are different, right? So let's try to understand the limits a little bit. And let's say P is equal to, what I will do is I'll put the first term. When R is equal to 3n, what is the first term? It will become 9n square plus 13n square minus 7 into 3n into n by n cube plus, and now I'll write the summation sign. So since I have already used up 3n here, so it should start from 3n plus 1 and go on till 4n minus 1, right? And this is the summation thing, and the whole thing I have replaced. I will not be writing this again, right? So P is coming out to be equal to, let's evaluate this. This is 22n square minus 21n square. So n square by n cube plus summation r goes from 3n plus 1 and 2r goes to 4n minus 1 of this entire thing. I'm again not writing this. This is the whole thing, right? So clearly what you're getting is P is equal to 1 by n plus summation from r goes from 3n plus 1 to 4n minus 1 of this thing inside the bracket, right? Now let's look at Q. I'll just erase this and make some space here. Let's look at the Q part. And what you will see is Q is equal to, so it is starting from 3n plus 1, right? So let's start from 3n plus 1 just like we did here. So summation from 3n plus 1, r goes from 3n plus 1 till, I will not go till 4n because here I have 4n minus 1. So let's go till 4n minus 1. R is equal to 4n minus 1. This bracket plus I have to add an extra term when r is equal to 4n, right? So let's do that. If r is equal to 4n, I will put it in this, becomes 16n square plus 13n square minus 7 into 4n into n by n cube. So basically Q becomes summation from r goes from 3n plus 1 to r goes to 4n minus 1 plus this is 29n square minus 28n square. So again n square by n cube, which is again 1 by n, right? So now you are noticing that P and Q are both equal. This summation part is also same of 3n plus 1 to 4n minus 1, and the addition is also same, plus 1 by n and plus 1 by n. So what I'm getting is P equals to Q, which is not there in any of the options. And I feel like there is a mistake with the options here. Now, why do I think like there is a mistake? Because first of all, they are assuming that P and Q are different, but actually P and Q are same. Secondly, I feel like the question is actually tending to ask something like this: limit n tends to infinity P. If it was a limit n tends to infinity P, then I would have done limit n tends to infinity of 1 by n plus this summation from 3n plus 1 to 4n minus 1, r is equal to, and this expression here I will keep r square plus 13n square minus 7rn here, and I will divide by n square here and add a 1 by n outside. Actually it is divided by n cube, so I put a 1 by n outside, and this is my thing, this is my calculation here. If there was a limit n tends to infinity, which is not there in the question, so limit n tends to infinity of this will be simply 0 plus limit n tends to infinity of this summation, where r is going from 3n plus 1 to 4n minus 1, and we have this inside part can be written in terms of r by n. So r by n whole square plus 13 minus 7 r by n. and outside I have a 1 by n. Now, if you have done definite integral as a limit of a sum, your r by n takes the place of x, 1 by n becomes dx, and limits come by taking what are the values of r by n as r goes from lower limit to upper limit. So in here, the lower limit was r is equal to 3n plus 1. So r by n will be equal to 3 plus 1 by n. As n tends to infinity, r by n tends to 3, and upper limit will be r by n will tend to 4 minus 1 by n, where r by n will basically tend to 4. So this value will be integral from 3 to 4. Instead of r by n, I'll write x here. It will become x squared minus 7x plus 13, and 1 by n will become my dx. So if there was a limit n tends to infinity p in the question, then I would have said that this is the actual value of that, and that comes out to be 5 by 6, right? But the question doesn't have any limit n tends to infinity, and the question is just a finite sum. It is a finite sum. So first of all, we have p equal to q. So both the signs should be same, right? It cannot be that p is greater than 5 by 6 and q is less than 5 by 6. It has to be either p greater than 5 by 6 or p lesser than 5 by 6. And here it feels like if there is an finite sum, this integral will tend to 5 by 6, and there is a plus 1 by n here, right? It might be p greater than 5 by 6, but we cannot be sure. So I feel like something is wrong with the options here. I hope you understand my logic here. We'll move on. We'll move on to the next set of questions here. Question number 13 and question 14 are part of one paragraph, and these are fairly straightforward. So I'll quickly give you a hint of what to do here. Question 13 says Fn cos theta is equal to cos n theta, and he gives an example of, he says Fn is also a polynomial of nth degree, polynomial of nth degree, and he has given examples of f2x is equal to cos 2 theta, which is equal to 2 cos square theta minus 1, and if you write cos theta as x, it becomes 2x square minus 1. f2x, where x is cos theta, f2x is 2x square minus 1. Question 13 now looks at x plus root over x square minus 1 whole to the power 10 plus x minus root over x square minus 1 whole to the power 10. You just put x is equal to cos theta here. This becomes cos theta plus I sine theta to the power 10 plus cos theta minus I sine theta to the power 10. And you use De Moivre's theorem to get 2 cos 10 theta. It is straightforward application of De Moivre's theorem. So that is basically 2f10x. So that is the answer here. And question 14 is simply an expansion of f of 6x. F of 6x will be, if x is equal to cos theta, you have cos 6 theta. You have to expand cos 6 theta. So the way you can do it is 2 cos square 3 theta minus 1 and use the expression for cos square 3 theta. 4 cos cube theta minus 3 cos theta whole square minus 1. And that after expansion, you will get the B option in question number 14. So 13 and 14 are pretty trivial. We'll not discuss it further. The next paragraph is also fairly easy. I will just give you a hint of what to do. It's an integrals. It's about integrals and indefinite integrals, so to speak. So you have 2x minus 3 to the power half divided by 2x minus 3 to the power 1 by 3 plus 1 dx, right? So this was the integral that you're supposed to evaluate. Now, I don't like these half powers and 1 by 3 powers. I don't like fractional powers. So what is the substitution that you would naturally make to remove these fractions? I don't want to remove one fraction and be left with another fraction, right? So I will take 2x minus 3 to the power 1 by 6 as my t, because what that will do is that this one will become t cube and this one will become t square, right? So let's simplify this a little bit. 2x minus 3 becomes t power 6. So 2 dx becomes 6 t power 5 dt. And here we have t cube by t square plus 1, and dx becomes 3 t power 5 dt, right? 2 cancels the 6. And therefore you have integral of 3 t power 8 by t square plus 1 dt. This is my question. And this is a fairly standard question, 3 integral t power 8 by t square plus 1. What you should do is do long form division of t power 8 by t square plus 1. And I will show you how to do that in a line. You can just write t power 8 as t power 6 into t square plus 1, but you get an extra t power 6. So you should subtract t power 4 and t square plus 1 to cancel the t power 6. But now you have an extra t power 4 minus. So you should add 1 t square plus 1, and you have plus t4 power 4, which cancels that, and plus t square. But you didn't, did you want a t square? No, you didn't want a t square. So minus t square plus 1. So this cancels t square plus 1, but it introduces a minus 1. So I have to just add plus 1. So this is the expression. So t power 8 by t square plus 1 will be basically t power 6 minus t power 4 plus t square minus 1 plus 1 by 1 plus t square. Now integrating this is basically doing integration of all of these terms part by part, and you will realize that the answer comes by integrating this, which is tan inverse t. So tan inverse t is tan inverse 2x minus 3 to the power 1 by 6, and there is an outside 3 factor here. So you will get the answer here in a straightforward manner. Question 16 is also similarly obvious, so we will not spend too much time on it. Question 16 says integral of dx by cube root of x plus 1 and x plus 1 whole square and x minus 1 whole power 4 is equal to k times cube root of 1 plus x by 1 minus x, right, plus c. And you have to evaluate the constant k. So since this is already given, that is obvious hint that this should be taken as your t, because here what you're getting is dx by x plus 1 to the power 2 by 3, and x minus 1 can be written as 1 minus x because the power is 4 here. X minus 1 power 4 is same as 1 minus x power 4. So this is 1 minus x power 4 by 3. This integral is given. And since similar expression is here, the obvious suggestion is basically that take 1 plus x by 1 minus x to the power 1 by 3 as t. So I can write this as t cube. And once you do that, it is fairly straightforward. You just follow through the steps, differentiate this here. When you differentiate, you will get basically, just hold on for a second, you get 2 dx by 1 minus x whole square is equal to 3t square dt. So dx basically becomes 3 by 2 t square. This becomes 3 by 2 t square into 1 minus x whole square into dt, right? Dx is this, and this side, remember that you have to put t as 1 plus x by 1 minus x is t. So therefore 1 plus x to the power 1 by 1 minus x to the power 1 by 3 is t, right? So let's divide this by x plus 1 by 1 minus x whole to the power 2 by 3. Then you have to multiply 1 minus x here, 6 by 3 you have to put, right? Because notice that this denominator right now is the same as this denominator. So this is my t actually. So t to the power square, this is t square actually, t square, and this becomes your 1 minus x square, which cancels with the numerator, and t square also cancels. So eventually you end up with 3 by 2 t as the answer, and 3 by 2 cube root of 1 plus x by 1 minus x basically will be your answer. That is fairly straightforward. You will be able to get it yourself. So this was till question number 16 in our problems. The remaining, I'll get to it in a bit. See you next time.